Hey Cameron, how are you doing this week?
Good, good, good. How are you doing, Akash?
I'm doing well. So, we want to cover a bunch of topics today. We want to start with Google's Gemini launch and how it has sort of affected Google's stock price. So, you want to take a shot at it and give the audience a view as to what's happened, what must have been, what must have gone wrong in Gemini's execution, and we'll
Yeah,
go from there.
yeah. I mean, so it seemed like GenAI was fairly powerful in the sort of, let's say, the fact sheet, right? It seemed to outperform GPT-4 on most problem tasks. But the problem was when they sort of, uh, what do you call it? When they sort of demoed the model had some, let's say, interesting visualizations. So they used their image creation tool, and the image creation tool created basically images, let's say Vikings that were like African American, that were black, Nazis that were like Asian, and this resulted in a quite a bit of a kerfuffle because again, I think they were trying, I think, to make the model very diverse and inclusive, but the model, they probably went too far, and so the model, made Vikings black and Nazis Asian, which is not realistic and also offensive, even
So,
though they were trying to do that.
logistically, did they not test this? That's what must have gone wrong, right? Logistically, I'm assuming they didn't test any of this, and I think they must have released it. But for a company that big, this is like this is like a major, faux pas. And I think it. What do you think must have gone wrong? Like I know their intent must have been that, but they would have tested this at some point.
Yeah, I mean, I think large language models now, like the big foundation models, are huge pieces of software. And typically, when you release huge pieces of software, you have an alpha release and a beta release and stuff like that. And you're probably doing this internally before you sort of demo it to other people. So I don't know if they had like an effective sort of like alpha or beta for their software, but you definitely should have a really extensive alpha and beta release just to make sure everything is ironed out, right? And I think partially they also probably tested it internally, but like the internal Google engineer is going to use Gemini very differently than like us regular people who have different interests, right? Like the internal Google engineer is probably going to worry about code, going to get, code production, right? Whereas most of us, we might use code production, but we'll also ask it things like, show us a picture of, let's say, a Viking, right? And that's not something that their internal engineers are going to be focusing on. So I just wonder if they spent too much time evaluating internally and not enough time evaluating with the actual people. Yeah.
And
Uh,
I think, given the fact that they were one of the pioneers in the field, and they also have major assets like DeepMind within their structure, so they must have been on top of even OpenAI paper, right? Attention is all you need is largely Google employees who wrote that paper. So they missed that, let's say, a huge shift because they want to be more cautious. The whole idea when OpenAI released their ChatGPT, and the people were asking as to why Google, which pioneered this whole field, hasn't released its version. The idea was the at least the popular air in the room, that if the air in the room had a voice, that voice essentially said, uh, majority voice essentially said that Google is more cautious. They're not as playful as OpenAI, so they want to take all the precautions that are necessary to release it properly. That was their whole premise of not releasing something which is half baked. Let's say
right.
now, having that premise, now they release this. It goes on the, it goes against everything that they stood for, that they are more cautious company, they want to be careful. This is totally haphazard. So given that, it's like hard to justify anything now, when some people are of the view that 10% of the people will be let go, and including the CEO. But that's an interesting turn of phrase.
I'm curious, what do you think this means for the competition in the large language model space between, let's say, Google and OpenAI / Microsoft, right? What do you think competition-wise, this sort of mistake, especially because OpenAI seems to be, like operating very effectively so far?
I think that this is great for a lot of young companies like Perplexity AI. I mean, that they're, salivating at this prospect. That
Tell me
I mean,
about
another
Perplexity AI.
Gartner report that came out, which essentially said 25% of search business will go down over a period of time. That's new market entrants and market participants being in the field, trying to take market share away from the historically monopolistic search business. So this is great for AI companies. So I am very excited about this, not because I'm celebrating the downfall of a great giant company like Google, but it opens up opportunities for other companies to, take a sledgehammer and carve away some portion of a small market, which is gigantic. So that's a net positive from all this. I hope enough companies get into it. And you want to talk something about liquid AI and its
Yeah.
fundraise. And I'm assuming they will do what Perplexity AI has done, wherein they want to be an entrant in the market. And because a lot of people are looking at alternatives for Google, they might, carve out a niche for themselves.
Yeah, so Perplexity AI has caught a lot of attention recently, but tell me what the company is. I'm not super familiar. I've come across the name a couple times, but I'm not super familiar with what Perplexity AI does.
Perplexity AI is started by a guy by the name Arvind. Is his first name. I think I looked at his bio. I think he did his undergraduate from 2013 to 2018 from Indian IIT
Right,
in electrical engineering. And then he went to Berkeley from 2018 to 2017,
right,
2018 to 2021, 22. Then he did a stint for a year in Google, a year in OpenAI. That perfectly set him up to, essentially go and start his own company. That's
right.
essentially the bio. So if you think about uh, uh, vintage in terms of how much street cred he has. I mean, he checks all the boxes, but I think he's just as new as anybody else on the block.
Right. Mhm.
Like he graduated in 21
So,
with a PhD, so he's pretty new,
mhm,
but he has caught a lot of attention, and he has released his uh, let's say the app, which essentially is an alternative for OpenAI, and
mhm,
he has signed up deals with mobile manufacturers to have his app as a default option before they buy. Meaning, like there are deals that you can tie up with, especially in a country like India. There is a company called Nothing, which is tying up with Perplexity AI. Nothing is a very big company. It's started by a Chinese entrepreneur, but
mm,
that kind of deal ensures that these are the kind of deals that Google signs up with mobile manufacturers, wherein all the Google toolkit is available even before you install them.
mm.
So I think they're making major strides, and I don't hope, I'm assuming the stock value of that company, which is currently pegged at $500 million,
Right.
will go
100 million.
significantly higher.
Oh, cool. Yeah, so you talked about, I think Perplexity AI is like an answer engine, right? So it's different than a
Yeah.
search engine in the case where, like, you say, like, how do I cook cacio e pepe, right? And it will tell you, use the pepper, use the cheese, use the pasta and whatnot. Instead of just searching for, a recipe or something like that, which is cool. But I think that brings us to the Gartner thing, which you mentioned, where search engine volume will drop 25%, right? I am curious about this, and then maybe it's true, but I think one of the things is there is a difference between search and large language model query, right? Like I would never query into a large language model, like how do I draw? I would never query into a large language model, like I need to buy a charger for my iPhone. I would just put that into Google, right, and then buy it off Amazon. And so I do think there's like, Gartner does predict search engine volume will drop, but I do think there's a lot of things that search engines have a comparative advantage in. For example, what I just said, but there's also things that search engines are not as good at. But I also would imagine that many of the things that search engines aren't as good at, which let's say like how do you code, how do you write code that will predict GDP in the future, right? No one's entering that into Google anyways, I think. So I wonder, maybe the pie just gets bigger and maybe search engine volume doesn't drop, but maybe the pie gets bigger. That's me being sort of contrarian. I'm not sure though, right? What do you think about that?
So you're basically saying it's a net positive game. It's not a zero sum game. It's definitely
Yeah.
not net
Yes.
negative game. It's
Right.
net
Right.
positive, wherein enough market participants will make the pie significantly bigger than what it actually is. In terms of the pie of the AI as a percentage of the overall GDP, and hopefully as a stimulant to the overall GDP, wherein the GDP also becomes bigger.
Yeah, I mean, yeah, the total amount, like, so, I mean, like Peter Thiel, I think it's Peter Thiel. Someone talks about, like, if you're making a startup, right, your innovation better be 10x better than what's out there, because there's a lot of inertia, right? Like, if, you give me a 50% better raincoat, I'm not going to go out and buy a new raincoat. I already have a raincoat. I'll keep my raincoat, right? And so one of the things I worry about here is, there are certain things where LLMs are better, but many of those things, they're not 10x better, they're maybe 50% better, especially when you consider the fact that it is more costly. Each LLM query is hundreds of times more costly than a Google search query. This will improve as you do things like, I don't know, like quantization, distillation, and stuff like that I'm sure OpenAI and everyone is already doing. But even so, search is just much cheaper per dollar, not to mention the fact that you have to spend hundreds of millions of dollars training these large language models. And you train GPT 4.5, and in 2 years you have to replace it with GPT 5, right? And 4.5 is upwards of $100 million to train, and you use it for a couple years, and then you have to move on, right? And so that's one of the things I think about. I don't know. Like, on the one hand, I do sort of sympathize with the fact that Google is in between a rock and a hard place, right? Like, if they don't design large language models, some of their search will move to other companies like OpenAI. But if they do design large language models that cannibalize all their profits, because my guess is large language models are less profitable because they're more expensive to do per query, right? But at the same time, I do feel like there are a lot of things that search is good at and better than large language models, mostly because search costs a lot less, but also because, like, you don't need to ask a large language model to search for Google for you. You can just type that into Google, and it's more effective. That's just sort of my opinion. I'm curious what your thoughts about this are.
In terms of like market positioning, in terms of size right now, OpenAI is hitting what, 2 billion a year, like
2 billion
1.5 billion.
queries?
No, 2 billion in terms of dollar amount collected. In terms of revenue is about 2 billion.
Okay.
Google is much bigger, probably like it's
Yeah,
200 billion, probably
billions.
more than 300 billion in search
Yeah.
alone. I mean, apart from that, other businesses. In terms
Right.
of number of queries, I haven't looked at that number. Do you have any stats as to how many queries that Google get?
I
Google
did
is ginormous.
Semi-analysis published something on that at one point. I think though the number of Google queries is something like 100x more than the number of, or 100x or even 1,000x more than the number of LLM queries, especially when GPT. This was when GPT 3.5 was just released, but it's some ridiculous, much higher time, and it's true, right? Like, half of the things that I want to search on Google are just like, find me something. I don't need a large language model to find me on the internet where this thing is, right? All I need a search on Google. But yes, I'm sure for other things like recipes or understanding how to code X or Y, LLMs are much more useful. But even in this case, I don't know if it's 10x more useful, right? Like Stack Overflow, searching for something and finding it on Stack Overflow is pretty easy. Yes, it probably takes 10 seconds less if you use an LLM, but is that 10 seconds really that meaningful? I don't know, right?
Yeah, and I think a lot of people don't use Stack Overflow. I mean, if you're
Yes, that's true.
technically proficient, probably you would be familiar with Stack Overflow. But there are a lot of people who are lay people
Right.
who have never heard of Stack Overflow.
Yeah,
Another interesting query that we never discussed previously was Apple shut down its car business. Apparently, 2,000 people were working
I
car
didn't hear
business.
this.
Oh, they wanted to do a car, and they had hired about 2,000 people who were working in that division, half of them working on autonomous driving. And they shifted about 1,000 of them, like 2,000 people, to other organizations within Apple. So that's a huge development. And I probably think they need some reinforcement of those resources into this AI battle. So they are also thinking that this seismic shift, so to speak, is too big for them to miss out, and they can do the car later or never. and focus on this because this is more survival.
Yeah.
Do you think it's survival, and that's why you think the AI revolution has something to do with the fact that they shut down the car operation?
Well, I think
We
partially
can only
Apple.
speculate.
I think Apple is notorious for having a, let's say, more limited research department than the other big tech firms. So I think Apple and Amazon are sort of like this. Amazon has much more applied research. But I would say like Facebook and Google, and then Microsoft via OpenAI and Microsoft Research have the largest sort of research teams of the tech companies. And then Amazon has a lot of applied research, and I don't think Apple has very much in terms of both applied or theoretical research, right? And so that's one thing, and it's just a philosophy. I think Apple is obviously more of a hardware company, so they don't need to do as much machine learning research. But I mean, on the other hand, self-driving cars is really hard, right? We talked about this before, but like their edge cases, there are so many edge cases, right? Like it's even after 100 million miles driven or something like that, you're still going to get cases that the thing has never seen, right? Like let's say you have, like ice, and then someone walking across the ice and they fall on the ground, right? There's you probably have never seen that in your data set, right? Something similar. And so the problem with self-driving cars isn't so much the coding, and reinforcement learning is a pain to get working, so that's also a problem. But the pain is the fact that there are millions of edge cases, and so no matter what you do, you need to get 100 million miles on the ground. And I imagine, I don't follow Apple's autonomous vehicle division, but things like Waymo, Cruise, and some of the others, these guys have tons of miles on the street, and I don't see Apple in the same ballpark. At least in my research, I haven't come across Apple driving coming in the same ballpark in terms of the number of miles driven, right? Like you can get to sort of like assisted autonomous driving with very limited number of mileage, right? Like couple 100,000, right? Like what George Holt was famous for building, basically an app that allowed you to do custom driving, and he based it AI assisted driving, right? You still have to keep your hands on the steering wheel and look, but it will turn itself. You only need, a couple thousand, 100,000 of miles, and you can do that. But if you want the human to be able to sleep and the car to just drive no matter what, it's the edge cases that are the problem, right? And that has always been the problem. And the only way you can get around the edge cases is literally doing a lot of miles, and so you get, see all the edge cases, basically, right?
Correct. Correct. And given that, I'm assuming there'll be more companies that'll come out. Do you want to talk about Liquid.ai's, the paper that they came up with probably in 2020, and what's their unique perspective or unique take or the use case that they have figured out, as a result of which they've raised this, enormous seed fund?
Yeah, I'm curious. So yeah, they raised, I think literally this week or a couple of weeks ago, they raised $36 million in a seed round. So I don't know what their valuation was, but they raised $36 million. I mean, we looked at the team a little bit. I'm curious what you think about Liquid AI in terms of the tech. I feel like, the tech, was written, the paper was written in 2020, and I didn't find that, it caught on super hot. It was a super hot sort of innovation that caught on a lot. It's got 200 citations, which is, reasonably good, but not something that I would imagine you drop everything and build a business around, right? But curious what you thought.
Yeah, I think the one good thing about this paper is like it's very mathematical, so it makes you think like, oh, at least they've done something here, which is not just architectural, engineering stuff, wherein like you just change the architecture of the model that you're building, and that kind of works. Parallelization. They've done some theoretical work, so that is good. That's on the good side. As to what they're doing, I think I've just heard this for the first time, so I mean, my take on it would be, as uncertain as I think the opposite of, let's say, the certainty of the rising sun. So if there is an opposite of the certainty of rising sun, that's my take on this company, pretty much, because I haven't heard of it at all.
you mentioned also this is like a team thing, right? Like these are all MIT CSAIL people, and so
Oh
if
yeah,
you're
yeah, that's
MIT
one.
CSAIL PhD,
Good. Finish with that.
I was going to say, if you're MIT CSAIL people, like you can, polish a turd and probably get 100, $10 million in seed funding, right?
I wouldn't go that far because I've seen a lot of C-cell people
Okay.
trying to raise even 2 million and they haven't been able to do so. So I
Okay.
wouldn't go as far. And there are a lot of people in, let's say, I wouldn't want to mention names. Let's say in
Right.
the management schools, loans.
Sure.
Let's not take the school names, but they are all like former founders. Some have gotten exit. It's not that easy to raise money unless you have some MVP which works, which is about to take off, and
Yeah.
that's when people want to put money because they want to minimize the risk and they don't want to be the one holding the bag, let's say. And if somebody has raised 36 million, they've got significant market cap, or like they
Yeah,
have
you're right.
something.
Yeah,
So
they
it's
got
not
some.
as easy as like just because you're a faculty at MIT, because there are a lot of faculty members who are
Yeah, sure.
struggling to raise money and it's not that easy. Sure,
Yeah,
it helps
maybe.
better than, let's say,
Better than
northeastern.
Michigan, let's just say, right?
No, or northeastern, just to be
Okay.
safe. And I don't think northeastern people would have any problems with it because they know that their market differentiator is something else. Their market differentiator is they are the co-op school,
Yeah,
and they're
right.
very proud of it. And this
Yeah.
is great. Everybody knows
No,
their market properly. And
I've
co-op is
actually,
one such opportunity. I wonder why no other university doesn't have a co-op. It seems like a slam dunk opportunity. Just have this co-op, and there'll be a lot of students coming to your school. Apparently, they're the only
yeah.
university which has figured this out, and they're very happy with it. What do you
Yeah, I
think as to why this slam dunk of an opportunity of
mean,
a policy thing? If somebody is of the, let's say, hierarchy of dean, if somebody is a dean of a university, can easily implement this, but apparently nobody has implemented it.
yeah, I mean, so I just to point out, like, I'm super impressed with the Northeastern students, undergrads, masters, and PhD students, because whenever I'm at an event, there are usually 5 or 10 Northeastern students, either bachelor's, mostly masters in AI and stuff, like just networking and meeting people, right? And so that's really awesome to see. Essentially, people getting out there and trying to get internships. And like they don't teach hustle in college, right? And I think, or master's degree, and I think hustle does matter. Like not only it's not what you know, but it's also who you know, right? And that those skills are super important. I don't see that as common in other places. MIT, I'll see 1 or 2 MIT PhDs every once in a while at these events, but you just don't see like everyone I talk to, every third person I talk to is some Northeastern students that's hustling for a co-op, and that's a good skill to have, right? I don't know why other schools don't do co-ops, right? I think one of the things though that may bother people is basically you're paying to do an internship with someone, right? And it's definitely an amazing value proposition for Northeastern because essentially they need to spend zero money that semester, while the student, basically is in a co-op. But at the same time, I do think it helps students as well, basically develop their machine learning skills, and not only develop their machine learning skills, but their experience working in industry and sort of handling the types of things that industry people need, right? That
Yeah,
being said, I don't see a lot of people moving from. I mean, there are certainly some people moving from Northeastern to like PhDs, but that sort of co-op is maybe less useful if you're moving to academia, right? So there is, maybe some tension there, and maybe people should have the choice of whether they want to do a co-op or not. I don't think that's true in Northeastern currently. I think currently everyone has to do a co-op, if I'm correct. But
that is true. That is true. And if you want to wear an economist hat, is
Mhm.
it is this due to geographical agglomeration? It's because Northeastern is based in Boston, which makes it easier for it to implement the co-op. And let's say, so if you're based in Pittsburgh, even though Carnegie Mellon is in Pittsburgh, it's much harder because there are a lot of industries, and historically, this Middlesex County is one of the largest beneficiaries of all the R&D money that's been spent over 80 years. So, do you think it's because it's in Boston, it's much easier for a university to have this kind of a program, and would it work counterfactual if you want to hypothetically test this, would this work in another city where a university will, roll out this policy of co-op, and would it be as effective as Northeastern?
I mean,
Wherein I'm giving credit to the Northeastern University
right,
to come up with this concept, and all glory to them, and
right.
hopefully their ranking will improve and they'll be one of the pioneers in this field. Given that, do you think it will work in other cities?
I mean, I have friends that do the co-op in Northeastern, and essentially, like, you don't have to do the co-op in Boston. I think, yes, I think you're right. It helps that Boston is like the center of tech and the agglomeration sort of, tech center of the world in some sense, maybe after maybe San Francisco and New York, but, certainly the center of biotech. And so there are a lot of good jobs to be found in Boston in terms of tech. I also imagine, though, like, there are humanities students at Northeastern, maybe. I don't know what sort of co-op they're looking for, but I think the very fact that you got a lot of universities, you got a lot of businesses, you can find good jobs, at least from the tech sector point of view, and even in the finance, you can find co-op jobs as a finance person or a tech person. Don't know about if you're a philosophy person or whatever, but that being said, the Northeastern system does not only allow you can take a job anywhere, I think, for your co-op, and maybe in the United States, but you don't have to be in Boston. I think that's also, I think a benefit, right? That you can essentially, you can go to Austin or something like that, right? So
Sure. And one of the papers that came out this week that we probably had to chime in is the 1.58 bits paper. The era of 1.58 bit LLMs, or 1-bit LLM. The era of
yeah,
1-bit LLM is the title of the paper, which begs the question: why didn't they, go for 1-bit is all you need as a title name and title?
yeah, that's a
Looks
good
like
idea.
that would have been a nicer title.
Yeah,
Or
a bit is all you need. Yeah, that's a good one.
here's my 2-bit, or here's my
Here's my
1.5 bit. Right? Here's
there
my,
we go. We are so funny. We crack each other up. Jeez.
yeah, but what's the basis of it? If I understand it right, I think it's this goes back to the paper that somebody had written in 2016. I think Yeshua Bengio was involved in that.
I mean, he's involved in basically every deep learning paper now, right?
He's involved in every deep learning paper. That's
Yeah.
makes sense. But instead of substituting at the inference level, instead of substituting the 16-bit floating point as weights that you have to add on in matrix multiplication, they're just giving out +1, -1, and 0.
Right.
So you want to explain your version of it? Obviously, it has huge implication in terms of throughput, computation, memory, latency. It scores well on all of these based on the empirical statistics that have been published. So give us your take on the 1.58-bit LLM paper.
Yeah, I mean, with the caveat that you've seen this paper and read this paper much more thoroughly than me, so feel free to add anything. The thing about this paper, if I'm right, is they use this 1, 0, -1 in training, right? They don't just distill it and quantize it in inference. They do this in training, right? Is this correct?
So that's what I read in the paper, but there were a lot of comments historically wherein people looked at some people from IBM. This was in the Y Combinator blog, wherein a bunch of people said that historically there was a view that training in floating point bit networks is beneficial, and because you won't add to the weights over a period of time, it's much better at the inference stage to just do ternary bits, meaning +1, -1, 0. That was the larger theoretical underpinning, is what one person was claiming. But I didn't actually check and verify back again whether it was training and inference. I had to look that up again. But that theory seems fine, because the key idea that this IBM veteran who worked on this in 2016 mentioned was the idea is marginally over a period of time, you don't add to the bits. You only add to the bits without a prior. Once
Sure.
you have a prior, you won't make such much of a significant contribution every time the gradients are computed. Does it make sense from theoretical
Yeah,
point of view?
yeah. I mean, I wonder how they back. So one thing I wonder is how they do back propagation if they do it in training time. Um, sure, there is a way, but I'm curious how. I mean, one thing they could do is they can back propagate between -1, +1, and 0, and then just round to the nearest one, right? I imagine that won't work super well, but I don't know. Um, but
But I
I
think they're
guess
hitting they're hitting the direction every single time.
yeah. Okay. Yeah. I mean, I don't know. I mean, back propagate. I feel like back propagation would be weird with 1, 0, and -1. But I mean, the other thing is most of the time when people talk about quantization, you only do it for inference, right? Usually, you train the model in what 32-bit or 16-bit floating point operations, 16-bit whatever, not floating point operations. Sorry, 16-bit, and you train it, in floating point. And then you distill it. You essentially convert these models into sort of quantized bits to save on inference cost. But I'm not sure. I mean, maybe they found a way to train 3 bits. That would be really, really impressive. I again haven't read the paper in super detail. But yeah, traditionally, I think what people do is they train the model at at 32-bit or whatever, very small. Very large number of bits and small number of differences between numbers. And then you get another model, an inference that basically has less bits, so requires less memory and computational power to run in terms of like inference, right? But I don't know. I mean, maybe they found a way. I don't know. I guess we have to look at the paper in a little bit more in depth. But it would be very impressive if they really, I think, figured out a way to do training with these three basically 1.58 bits, right? So that's natural log of 3 essentially, right? Or no, binary of 3. So what is it called? The second log of 3.
Base 2, you mean?
Yeah, base 3. Yeah, log base 2. Yeah, of 3. Yes, thank you.
Yeah. So I think on that question, do you want? I mean, we should chime in on the Thorasio bankruptcy.
Right.
This is a company which raised lots of money in 2021, and I think it filed for bankruptcy protection this week. So essentially, this is a reiteration of the familiar thread that people have been following, wherein lots of companies, especially AI-based companies, raised lots of money in 21 cycle, where the capital was extremely cheap and people were investing for the future, and they were not able to sort of uh, cope up with the pressures of higher interest rates at the same time capital being not as abundantly available. So any thoughts on that? Because this is like a familiar story that other news agencies and segments have already covered, that capital in 21 was extremely cheap. And a lot of people made a lot of wrong judgments in terms of the companies that they have to fund and the amount of valuation and the money that got pumped into the system.
Yeah, so Thrasio is a roll up. Basically, what a roll up is essentially I don't know if Thrasio is sponsored by a private equity fund, but usually what they do is they'll buy, so what Thrasio would do is they'd buy Amazon storefront, right? So like let's say I sell, like knitted animals or something like that. And that was my Amazon store. Thrasio would buy my store and then buy, the other store that sold, let's say, like like jewelry, like what a stone jewelry or something like that. They buy another store and another store, and the idea is essentially they buy all these Amazon storefronts and use their expertise, I don't know, in Shopify analytics and all these sorts of things to make all these stores more effective, right? And this is essentially what a roll-up is. Essentially, you buy mom and pop or small scale stores, and then you use the fact that when you have a lot of these stores, you can use your scale to your advantage, right? And a lot of times, actually, these roll-ups succeed. Roll-ups in the mobile home market, like mobile trailer park market, do really well. Constellation Software is another roll-up that did really well. Basically, they buy vertical vertical market software. So essentially, they buy software companies that essentially make money on some vertical, right? So like point of sale for truckers, right? That may be one vertical. And Constellation, used this, had this playbook, and has basically compounded capital at 20 to 30% a year for the past 20 years, right? Other companies, Thermo Fisher and Danaher, are roll-ups in the biotech space, especially in terms of devices. XPO is a roll-up in terms of trucking. And so a lot of these things actually do really well. I was actually looking into, how many roll-ups fail and how many succeed, and many of them succeed actually, despite the high debt load. And maybe some of this is a survival bias, right? But other ones that have failed are Valiant, which was a roll-up of pharmaceutical companies.
Oh, Valiant Pharmaceutical.
Yeah. Super famous, right? The
Yeah.
company. Yeah. So they failed, and I mean the reason these companies fail is they take on too much debt. That's the only reason. That's the main reason they ever fail, and that's what Thorasio probably the problem Thorasio had, right? Funeral Home Service Corporation also failed. I think right before the COVID pandemic, which, if we're going to be gruesome, was unfortunate for them because they would have made a lot of money in COVID. But they failed too. And so a lot of the thing is, you pack on too much debt and the market goes against you, and then you can't, service that debt. But the other issue is I just don't know if there are large economies of scales of optimizing, Amazon storefronts. Like, you get some benefit from analytics. Maybe you get some benefit from the fact that people don't know how to use Shopify and all the Amazon apps, or all the apps designed for Amazon storefronts. But I really don't see why a roll-up of Amazon storefronts is like that great an idea. But curious what your thoughts are.
I mean, so these kinds of operations which buy operations of other companies and essentially provide distribution. I think in terms of business, what do they provide? I think roll-ups provide distribution.
Scale, right? Hopefully scale.
Yeah.
I mean, the argument is scale, but like, I don't understand how Amazon storefronts benefit from scale, other than maybe with some analytics stuff. But I feel like that's, second order.
And I think they also provide last mile sales.
Do they really? Oh, okay. That's.
Oh,
But
I
I mean,
mean, like,
Amazon does that too, right? So like, is there an advantage of Thorasio providing this last mile service versus Amazon doing it?
I think Amazon is so huge. Probably they allow these kinds of operations to go through because, like, if it accelerates their ordering and it improves their efficiency, they're fine with it. But I'm not sure. Apart from distribution, from what I can hear, I don't see distribution. And obviously, over a period of time, this distribution lends scale and it becomes pricing power. So it's very beneficial if it works in theory. But I think execution is hard in these kinds of operations. So I don't have much insights on it apart from what you have stated. So in terms of like interview questions, well, what I plan to do was every week we'll do some interview questions, and we have previously sort of discussed these differences that people might want to understand in terms of machine learning interviews if they're facing, like what's the difference between batch gradient descent and stochastic gradient descent, and why is this question important in the first place? So what's the motivation of this question being important? Why should people focus on it if they're doing machine learning, or even if they're doing anything quantitative these days? And if you can throw some light as to why that is the case, why is this question important, and why should everybody know this?
I mean, again, I think mainly you should be doing, stochastic gradient descent when you're sort of optimizing your models. Like a analogy sort of is stochastic gradient descent basically is probabilistic, right? So not taking the entire batches or not taking the entire data set at the same time, right? And the benefit of essentially stochastic gradient descent is it seems to metaphorically, it's like snowshoes on snow, right? There may be small holes in the snow, but the snowshoe will just walk over these holes, right? So if you imagine your let's say you imagine your loss horizon is like a function that has, maybe 2 or 3 local minimum, but also has a lot of, let's say, like sine and combined with sines and cosines, right? So there are going to be a lot of very small divots that are like with high frequency sines or cosines combined with, let's say, a parabola or an anabola with, not a parabola, but like a function with like multiple local and global minimum, right? So what the stochastic gradient descent, and this is old research, I think it still holds up, but I'm not sure. What's stochastic? It's like snowshoes on these signs, right? So you won't hit the local minimum in the signs. You'll step over them and you'll find the sort of global minimum where it is, which is a much larger minimum and not like, a very small hole essentially that is like local minimum. So that's one of the benefits of stochastic gradient descent. I'm curious what your thoughts about that are, especially in relation to batch gradient descent and stochastic gradient.
So I think this notion that the theorem is if you have the set which is convex, then you'll always find the global minima.
Right.
That's the idea. But usually, most of the cases, any loss function you're trying to run a gradient descent on, you will have lots of local minima. It won't be one global minima. So as a result, you do some version of batch processing wherein you take this small sample, you run a gradient descent on that, and you find lots of minima. And your job is to utilize that and somehow converge that to a global minima if it is available. And I think this batch gradient descent is essentially a trick to do portions of the job. Another, can I call this? I'm interested in hearing your view on this. Is it some kind of dynamic programming approach wherein you break the problem down into smaller portions and you just solve that part? And would batch gradient descent fit in that paradigm wherein you're breaking it down into smaller portions and sampling that?
Yes, I don't remember the name. Maybe it's like modular optimization or something, but there is a field in convex optimization which essentially does that, right? Like they essentially break down the problem into much smaller, maybe convex problems and solve each individual one, then like aggregate up. Is it called modular optimization? I'm not sure, but there is a literature on people doing that modular optimization. Let me see. I don't exactly know. Yeah, I don't know, but there is in the complex optimization literature or just general optimization literature, there is a sort of technique that does these kinds of things. It hasn't really, I don't think data scientists and deep learning people use it very much because gradient descent is somewhat magical. But I think there are ways that do that. I just am not super familiar.
Okay. And just to end this segment this week, what kind of jobs? There is a air of anxiety amongst people as to the kind of jobs that this huge step change function of AI is going to bring about. So, what kind of jobs are going to go first? And another way to put that is, is AI, or some people would like to call it synthetic intelligence. It's not not really intelligence, but the synthetic intelligence. What kind of jobs is it taking? Is it more towards it's taking more IQ jobs, or it's taking more EQ jobs, or is it a choice between the two? So how would you think about this problem and explain it to a layperson in a manner in which their anxiety is decreased to a fair extent?
I mean, so the good scenario, which has a good possibility of happening, is that the AI really helps us do sort of more grunt drudge work, right? So one example of that I had some friends talk about is essentially, imagine now instead of hiring like a junior analyst for a hedge fund, like someone that puts together slideshows and stuff like that, you just tell the AI, hey, like beautiful AI or something like that, hey, can you put together a slideshow which demonstrates, why, XYZ Corp should, raise funding, debt funding, right? Or whatever. Or you can imagine a lawyer, right? Lawyers, like, they have discovery and they have to go through 100,000 pages of 10,000 pages of discovery. Instead of sending that to a junior lawyer or paralegal, you just give all the data in some sort of vector database to AI, and then you look up relevant queries. And using this vector database structure is not new and not LLM, but you can also do LLM things. But all these things. I think machine learning in general, even before LLMs, were sort of going in this direction, right? So there are other things like, I noticed in Boston, like 10, 15 years ago, we used to have toll booths. Like people would actually take your money. Now you have essentially a computer vision system, which finds everyone's license plates and basically correlates that to a credit card and charges people money, right? And so now you don't need people that are sort of toll people. And hopefully those people will find other jobs. I mean, like sales jobs probably won't be automated by robots anytime soon. Higher level, like strategic jobs, or somewhat higher level jobs that are not as much grunt work will less likely be automated. And again, hopefully the good scenario is people will learn how to coexist, and the model won't, like, for example, take all our jobs and make us sort of all entirely without a job. Curious what you think about that. What do you think? What is that? So I just laid out, I think, the positive scenario. I'm curious if you think this positive scenario is realistic, and if there's a negative scenario, what do you think about that as well?
It just occurred to me that I have an interesting analogy for this. In the last 30, 40 years, anybody who's had one victory or who has created one brand in any given field, be it sports, capital markets, you tend to win more because you won in the past.
Yeah.
So the gains at the top are extremely nice for somebody. So another way to think about this is look at the greatest player in the world right now, LeBron James or Tom Brady. He was able to extend his career for more than 20 years. That is not usually the case for an average basketball player, or for that matter, an average professional. So the gains of being a winner can be maximized, as a result of which I think the new statistic on income inequality that I saw was the 1% of the top 1% of American wealth is greater. I mean, this was published by Mohammed Al-Arian. Al-Arian is his name?
Mohammed Al-Arian, yep.
Yeah, from Allianz Capital, I think Allianz Insurance. So he published that 1% of the capital is greater than, let's say, the entire middle class. So what is happening is there is consolidation of power in every sector of the economy because everything is so transparent. So if you have brand, that means you go to right college, or if you establish yourself in the eyes of the public as a winner, the chances of that person, regardless of what domain he is in, having multiple victories is highly likely today than, let's say, 40 years ago. And the downside of what you essentially suggested is that there'll be a lot of people who haven't had those victories. Let's say somebody who's 35 or somebody who's 40 or somebody who's 45 who hasn't had significant victories in their life. For them to succeed competing with somebody who's already had 2 exits. For example, if there is a startup founder at 45 trying to start a company, he would have an uphill task competing with another person who has had 2 exits, went to a great school, and then who's competing with this person who's doing it for the first time. That is the hard part.
Right? Is that what you're saying? AI will make that worse, right? The winners will win more, right?
Winners will win more. And I think the results are already there for people to see. If you have access to resources and better nutrition and better guidance, you can stretch your career. I think it would easily be the case that a future professional athlete will play for 25 years, which was unthinkable.
Right.
So that's the downside. The downside is the income inequality that we are tipping. What we see is the tip of the iceberg. The income inequality will become more drastic. And how that will lead to the social structure and political structure is something that needs to be seen. But that's the hard part. That's the downside of it. So the key, given all that, is ensure that you have some victory somewhere and use that as a catalyst to sort of push yourself. So I'm curious as to what you think of this winners getting multiple opportunities and consolidation at the top. It can be income consolidation and also opportunity consolidation.
Right. So what the econ literature has found is that not only is wealth, the standard deviation of wealth, essentially infinite or undefined. And what that means essentially is as you progress further and further into history, the standard deviation will get larger and larger as you go further and further in time. And so that means essentially there's no stable distribution. There's really no tail. The tail at zero is a tail, but the tail going up to infinity will get larger and larger over time. Not only is wealth essentially have an undefined standard deviation, but a lot of the papers in economics also find it's income that has a undefined standard deviation, right? And there's theories about that. You can look at sort of like stable distributions, like Levy alpha stable distributions, which have a long history of being research. Levy was Mandelbrot's advisor. And so, they have a large history, and also Levy-Lumberg central limit theorem. Again, like these central limit theorems deal with distributions that have infinite variance, and they also converge to certain types of stable distributions, just like random variables with constant standard deviation converge to some sort of Gaussian. But again, even wealth, even income there's evidence that just even income has infinite standard deviations. And that's like your thing, right? So like you get one win, you get promoted once, you're more likely to get promoted again, right? So that's the thing, the rich get richer. The standard deviation of not only wealth, but also income will increase over time, meaning that the richest and most successful people will get progressively more richer than the rest of us, right? And of course, there are ways to solve this, right? Like you can turn an infinite distribution with an infinite variance into a distribution with a finite variance. It's very easy. One of the things you can do is just say, if you make more than $100 million, you give all of it to the government, right? And that's one way to like make it, you have a finite state. That's of course a very extreme thing, but that's just to illustrate that there are transformations that allow you to turn infinite variance distributions to finite variance distributions, right? And so ultimately, that's maybe something we have to think about as economists, as policymakers. How do we stop this growth towards infinity of income and wealth? And it is possible, but that is definitely something we have to think about. And AI is probably, as you're saying, making this worse, right? For sure.
Yeah. And I think what you refer to is also termed in political circles as income redistribution.
Right.
But what they would say is, instead of taking our money, why don't you give more opportunities for people entering the labor pool, which helps the people at the top. I mean, that's both can be done.
Right.
And their real answer is probably the mixture of the two, somewhere in between. And hopefully either way, the society should function and go forward and not stop at any moment. So hopefully people will resolve that, right? So thanks a lot, Cameron, for joining this conversation, and hopefully we'll keep doing this every week.
Yep.
And viewers, if you are interested in any of the questions that we discussed, if you have any questions, please leave the questions in the comment section. We'll take them up in the following week. Thanks a lot for your time. Take care.
See you next week.
See you next week.